Okay, so let's see how you did when you solved and graphed some of these inequalities for number 2. Number 2, it looks like the graph, we have -2, -1, 0, 1, 2, 3, open circle on -2, open circle on 0, and it's it's a conjunction, so it's graphing in between the two of them. Let's go on to number 4. Sorry, I started on the second page and then we'll go back to the first page. Number 4, let's go ahead and get v by itself by adding 3. You have -4v is less than +8. When you divide by that -4, remember to switch that inequality and make that v is greater than -2. This is an OR statement. We're going to add 7. -2v is greater than 8. We're dividing by a negative again. And when we do, we're going to switch that and make it v is less than -4. Let's look at these when we graph them. They should graph away from each other. So let's see. We have, let's start at -10, -8, -6, -4, -2, and 0. Open circle on -2, everything that's larger will be to the right. Open circle on -4, and it says everything less than will be to the left. Okay, I'm sorry, let's go back up and look at these. On this first page, you had number 2 where you were also just graphing that inequality. Oops, I forgot to put it on the number line. So let's see, let's go by 1s, 2, 3, 4, 5, 6, 7, 8, 9, and we're going to get 10 there right at the edge. Less than 7, this is an OR, it's a disjunction, so it's everything smaller than 7. Greater than 10, and that's going to be to the right. So that was number 2. And then it looks like you had number 4 to do also. We got to get w by itself by subtracting 3. We get 4w is less than -8. Divide by 4, so w is less than -2. Or, let's go ahead and subtract 7. And we get -2w is less than -6. Let's divide by a -2. That's going to switch our inequality to w is greater than 3. See what this looks like. Let's see, -3, -2, -1, 0, 1, 2, 3, 4, 5. -2 less than, that's an open circle, everything smaller to the left. W is greater than 3 to the right, everything bigger than 3. Okay, so that is all we will do for our inequalities. Now let's go and look at our absolute value. We're going to look at equations and inequalities when we do this. To solve absolute value equations and inequalities, remember, absolute value is the distance between the graph of a number and the origin, or 0, on a number line. For example, when we have the absolute value of x equals 5, what can we put into that makes that true? What is 5 units from 0, the origin? Both 5 and -5 are. So this is an OR statement because it says x equals 5 or x equals -5. So anytime you have an equal, anytime you have an equation, an equal, it's an OR. And then the next one is x is less than, the absolute value of x is less than 5. This means that x is less than 5 units from 0. So if we go to the left, we get that it's -5, -4, -3, -2, -1. 5 units the other way to the right is 5, 4, 3, 2, 1. So this is less than. When I think of less than, I hear and, less than. That I know this is a conjunction, so it's going to be an and statement. It means that x is in between -5 and 5. Finally, we have x is greater. Greater, the absolute value of x is greater than 5. Greater or. This means that x is less than -5 or x is greater than 5. All right, steps for solving equations and inequalities. Here's your first thing. If it is an equation or a greater than inequality, you have a disjunction. A disjunction is or. You will solve two equations or inequalities that are separated by or. If it is a less than inequality, you will have a conjunction and you will create a compound inequality where you're isolating the variable between the inequalities. It is an and statement. Okay, so there's 7 of these. We're going to do there's 8 of these. Let's go ahead and do the odd ones together. We have the absolute value of 5x equals 20. So in purple, if it's an equation, it's going to be an or. How do we solve this? We take it out of absolute value, we set it equal to 20, or we set it equal to the opposite of 20, which is negative 20. To solve for x, we divide by 5. X equals 4. Or we divide by 5 again. X equals negative 4. When we graph equations on a number line, remember when we graph those that we are graphing just those solutions. These are not inequalities. So I can call this negative 4, 0, and 4. How do we show that? I have a solid circle. X can equal 4 or negative 4. Solid circle on each of those because either one of those make that absolute value equation true. Okay, let's go on to number 3. The absolute value of 3x plus 5 is less than 1. That's telling me it's an and, it's a compound. I take it out of inequality, write it like it is, and I make the 3x plus 5 go between negative 1 and 1. I take the opposite of 1 and put it on the other side of that inequality. I'm going to solve by adding 5 first, and I get 4 is less than 3x, which is less than 6. I'm going to divide by 3 because I got to get x by itself. 4/3 is less than x, which is less than 2. Okay, when I go to do this, oh, nope, that's not right. I'm going to start over. You want to know why? Because I did not subtract correctly. So I'm taking it out, and I get 3x plus 5 is less than 1. And in between there, I'm going to now isolate the 3x plus 5. So negative 1 is less than 3x plus 5, which is less than 1. I need to subtract 5. I added 5. So I get negative 6 is less than 3x, which is less than negative 4. Divide everything by 3. I get negative 2 is less than x, which is less than negative 4/3. That looks better. All right, now I graph this. This, again, is an and, is a conjunction. So I have negative 3, negative 2, negative 1, 0, 1. Okay, I probably should have left a little more room in between here. So negative 2, we have an open circle. Negative 4/3 is going to be a little bit to the left of negative 1. It's negative 1 and 1/3. That has an open circle. And this is everything in between here. So my graph looks very little, but if you made a better graph, it might look a little bit bigger. Okay, so far so good on those. All right, now let's look at some of these others that are also odds. Number 1, the absolute value of x plus 9 equals 3. Equals is an equation, it's an or statement. I take it out of absolute value, I make it or, and then I make it equal to the opposite. I'm going to subtract 9 from the left side and get x equals negative 6, or I'm going to subtract 9 from the right side and get x equals negative 12. All right, so when I go to graph that on the number line, I'm going to go by 6s, so negative 12, negative 6, 0, 6, 12. These are equal. One solution on negative 6, one solution on negative 12. Number 3 is also an equation. So it's an or. 3 minus c equals 3, or 3 minus c equals negative 3. I'm going to subtract 3. And when I do, I get negative c equals 0. Divide by negative 1. That's not changing the value, so c equals 0. I'm going to subtract 3. divide by, negative 1. And when I do, I get c equals 6. So I have two solutions, c equals 0 or c equals 6. This time I'll go 0, 3, 6, 9. I have a solid circle on 6 and a solid circle on 0. Okay, let's go down to number 5. Number 5, the absolute value of t divided by 2 minus 1 is less than 3. When I have a less than, it's an and. I take it out of absolute value and I set the other, not negative 1, I set the other side the opposite. So it's negative 3 is less than t over 2 minus 1, which is less than 3. What do I want to do first? I want to isolate t as much as possible. So I'm going to add 1 to itself, to negative 3 and positive 3. I get negative 2 is less than t over 2, which is less than 4. Now I want to get rid of that 2, that denominator. I'm going to multiply everything by 2. 2 times negative 2 is negative 4. 2 times t over 2 is 2t over 2, which is t, and 2 times 4 is 8. So I get negative 4 is less than t, which is less than 8. I'm going to go ahead and I'm going to graph this. So let's go by 4s. Negative 4, 0, 4, 8. Open on negative 4, open on 8. It's an and. It's everything graphed in between. Okay, let's go to number 7. Number 7, 7 times the absolute value of 3y minus 4. That's the absolute value. Minus 8 is less than or equal to 3. All right, so I'm going to try to isolate and get rid of everything except where the absolute value or the y is. I want to get, as much as y as I can by itself. So since it's subtraction, I'm going to add first. So I have 7 times the absolute value of 3y minus 4 is less than or equal to 11. Now I want to get rid of that 7. So I'm going to get 3y minus 4, that's still absolute value, is less than or equal to 11/7. Now I have to go ahead and create the and compound inequality by making it negative 11/7 is less than or equal to 3y minus 4. It's no longer absolute value, which is less than or equal to 11/7. Okay, so first I'm going to take and add 4. You know what? It's probably going to be easier if we get rid of this 7 first. Let's do that and see what happens there. If we go ahead and get rid of the 7 first, it just means we're going to multiply through everything by 7. So let's do that and see what happens. Negative 11 is less than or equal to 21y minus 28, which is less than or equal to 11. Okay, now let's go ahead and add 28. And when we do that, we're going to get, looks like 17 is less than or equal to 21y, which is less than or equal to 39. Now this is going to make it easier. Divide by 21, divide by 21, and we get 17/21 is less than or equal to y, which is less than or equal to 39/21. Okay. And let's see, it looks like, can we do any simplifying? It looks like 3 goes into 39 and 21, so that just might help us a little bit when we graph. So that becomes 13/7, and 13/7 is going to be just a little bit bigger, or a little bit smaller than 2. We're going to be really close to 2. And 17/21 is going to be, I'm going to leave a little bit of room between here, a little bit less than 1. So here we are at 17/21, and here we are at 13/7. Close circles, and we're graphing in between. Okay, so that's the end of this section. If you want to try the even, go ahead and just send me a message and I'll shoot you those answers. Have a good rest of your day.